Alright, we're doing today
2D and 3D shapes.
有为什么？
Yo, the lines are broken, bro. Hey.
不，怎么？
Alright, these are slide presenters. Me, Yong, Jermyn, Lucas, Jadon, and Jadon. I'll be doing points, lines, and angles. So, point is a location represented by a dot, like you. Angle is when two lines cross against each other, like corresponding lines. Next. Line is a one-dimensional object with length but no width, and just travels in one line. Just travels in the same direction.
Congruent figures. Congruent figures are two objects that are the same size, same shape, same value, same volume. Here are the example.
I will be doing line symmetry. Jermyn, next slide. A line of symmetry is a line that perfectly divides a shape in half. And if you were to go along the lines, both halves will match. Like this for an example. Dividing asymmetrical figures. Asymmetrical shapes do not have a line of symmetry, therefore they cannot be divided by a line into. How does a line of symmetry help? Symmetry is used when doing calculations that involve spheres, circles, and many other shapes, including triangles. This is an example.
I will be talking about lines and angles. So we're going to talk about parallel and perpendicular lines. So next, I elaborate. Huh?
Oh my god.
What happened? Okay, these are parallel lines. They never touch each other. They're the same height from here to here.
The example thing.
What? Oh, you two come here. Hi guys. Don't dance. Get
Don't
up.
touch each other.
Get up. Whatever. Come here to see. You can see.
It's not parallel though.
It kind of is. See, I put 2 foot here. Yeah, right. And I put 2 foot here. 2 foot here. Yeah, this is great. 2 foot here. 2 foot here. Yeah. Again. Perpendicular lines. Okay, bicep, they cross each other at 90 degrees. Looks like Jesus. Jesus. Yeah. Okay, next. Okay, these are the angles, the related angles. Yeah, continue next. Complementary angles. There are multiple angles, like 2 or more. They add up to 90 degrees. Yeah, next. Supplementary, they add up to 180. Very easy one. Adjacent angles is 2 angles that share the same point, like they join together. And then I'm not done. Vertically opposite angles. So 2 lines intersect, then the opposite angles will have the same angle. Yeah. Next.
Okay guys, I'll be introducing you to rotational symmetry. Rotational symmetry basically means something when it's rotated, it will look the same. Basically like this. Whenever it's spinning, it will look the same, right? Here's an example. Look at this thing here. Even though okay, now let's get into the more complicated stuff.
Oh my god.
Now let's get into the more complicated stuff, okay? This is order of symmetry. Order of symmetry is the number of times where an object can be replaced to the same position in less than 360 degrees. And here are some common usage of symmetry. design and art, architecture, and one of the most important of them all, mathematics. Here is the most biggest example of rotational symmetry. This is a circle. I'm more of a cat guy, but this is cute enough. As you can see, this thing is spinning. Next. However, whenever it spins, it appears the same. So, does it have rotational symmetry? Yes, it does. Rotational symmetry is like a dance, where an object looks the same whenever you turn it around. This basically just summarizes the whole entire thing. Now, next slide. Whoa.
Polygons and circles. So what is a polygon? There are two types of polygons, triangles and quadrilaterals. Triangles have an interior sum of 180 and quadrilaterals have an interior sum of 360 degrees. A circle is a set of points which have all the same difference from a given fixed point. These are types of polygons. You have a triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, and decagon. These are irregular polygons, and I don't feel like explaining them. These are triangles that can be identified by their side length. We first have the scalene triangle, and then isosceles triangle, and equilateral triangle. The equilateral triangle, what? Equilateral triangle has three same side length and three same angles, and the interior angle is always 60. The isosceles triangle has two equal. Now how do you want me to pronounce it?
You go away
Go away lah.
Isosceles triangle has two same side length, and the base angle, these two are always the same as each other. And the I'm not done yet.
Yeah, ask me to do it.
Yeah, they are.
Yeah, go on.
And the scalene triangle has no same side length and angle. And these are triangles which can be identified by their angle. First we got the acute angle triangle, next is the right angle triangle, and next is the obtuse angle triangle. The obtuse angle triangle, you see these angles, they'll always be smaller than 90 degrees. And the right angle triangle will always have 90 degrees. And let's see right angle acute. And the acute angle triangle will always have interior angles smaller than 90 degrees. To find the interior sum of a polygon, we basically take the numbers of sides, which is represented by n, and we minus 2, and after we get that number, we times 180, like this. Now, can everyone try finding the interior sum of this polygon?
Can I try?
No, why not?
No.
Why not?
Alright lah. A hexagon has 6 sides. So 6 minus 2 equals to 4. 4 times 180 equals to 720. Yeah, 720. So this is the interior angle. But to get a single interior angle, 720 divided by 6, you get 1. Then you get, so it's 120.
Let's see if Lucas got it correct. Lucas got it correct. Alright, next slide. The interior sum of a quadrilateral will always be 360, like I said before. So, can you guys try doing this?
Find X, guys.
Yong.
Yong Jun, go do it.
Wait, who said no?
Elsa, I would like to invite you on the stage.
Okay.
next, guys.
Oh lah.
Because you have
Oh my god.
No chat, it seems like she does not know chat.
This is C.
Have confidence.
We have no.
Oh, you did it. Oh.
Yeah, I tried to love it.
These are parts of a circle. Yeah, it's very complicated. Anyways, this line is called a tangent. This is the dot here. The dot is the center. The entire thing, the entire circle, which is basically like this line. This circumference.
Yeah.
Then that's the circumference. This orange part is the sector. What? Just this entire yellow part is the minor sector. This blue line is
Minor segment.
minor segment. This blue line is a chord. This red line, which is like from the center to the circumference, is the radius. And this line is a diameter.
it's a circle.
Okay. Who's it?
Plans and elevation. Next slide. So this is the 3D view like this bottle. Okay? And elevation is from the side to the bottom center. Like this. This is the plan view, it's from the top of the bottle. It provides a bird eye view from the top of the object, from the top basically. Next.
Oh my guys, that's it, guys. Any questions? Okay, guys, no questions? Okay.
Wait, I have one question.
No, you don't even have you are.
Where's the marker pen?
Oh, you're the damn presenter, bro.
What is this one?
You know what's the question? I want to know.